Hello, today we'll be solving this problem to help you familiarize yourself with how to find delta G using K and Q values, right? So for this problem, we are told that we have to use Appendix B, it's referring to the textbook, to find K at 298 Kelvin for the following reaction. Now, right off the bat, the 200K Kelvin should tell you that we're at standard conditions, right? Um, and the equation that I provided for you in the last slide was delta G is equal to R times T natural log of Q over K, or you can also do R of T is equal to natural log Q minus RT natural log K. Essentially, this will get you delta G, but it's not at standard conditions. Actually, the equation for delta G at standard conditions, which is what we have, will just be negative RT natural log K, right? And as you can see, that's basically this equation right here, right? So what happened to the Q? So if you remember, Q represents the concentration of, say, like a solution, so it would be 1 molar, or the pressure, it would be 1 atmosphere at standard conditions. And the natural log of 1 is just 0, so this would just go to 0. So that's how we get this right here, right? Okay, so to continue on with what we have, so we have, let's write what we have so far, right? We have RT, which is 298 Kelvin. R, that's just a constant. And then finally, we're trying to find K, so we also need to find delta G. Okay. Oh, and then right. And then so we want to find delta G in standard conditions. So how do we find delta G? So we actually use this equation right here. It's very similar to the change in entropy of the system, of the reaction, sorry. So it's just going to be the summation of the products, the moles of the products, minus the summation of the moles of the reactants, right? Now this equation should already be familiar to you. So we're just going to fill out what we have. Oh, I'm sorry, the unit for this is, sorry, joules per mole Kelvin, right? Okay, so let's do that. We're going to bring it down here. Okay. So for delta G, standard conditions, we're going to set that equal to 1 mole, 1 mole of NO2. And again, we find our delta G at standard conditions using Appendix B in the book, right? Or you can also look up these numbers, but again, they are provided. So we know that this number, according to the textbook, is 51 kilojoules per mole. And that's everything that we have in the product side. So we're just going to move on to the reactants. We have 1 mole of NO, and it's going to be times 86.0 0.60 kilojoules per mole plus half a mole times 0 kilojoules per mole. Right? And with that 0, you know, this just goes to 0. So we're just gonna be left with calculating the rest. So you should get that your delta G is equal to negative 36 kilojoules, right? So now the only unknown that we have in the equation is our K. So, you know, that's what we need to look for. So let's rewrite this equation so we can find our K. So we're going to rewrite it as natural log of K is equal to negative delta G over RT, right? And then if we just plug in what we know that our delta G is negative 36 kilojoules. Now, if you remember, our R value is in joules, so that cancels out. We have to convert our kilojoules to joules, and there's 1,000 kilojoules. Sorry, there's 1,000 joules in 1 kilojoule, so per 1 kilojoule. And all of that is going to be over our constant, 0.314, sorry, joules per mole Kelvin, joules per mole Kelvin, times the temperature that we started at, which is standard condition, so 298 Kelvin, right? And finally, you're going to get 14.53. Now we're not done because we have natural log of K is 14.53. And then so to get rid of the natural log, we have to erase everything, e to the power of that, right? So that cancels out the natural log. So we just get K to itself. So K is equal to e to the 14.53 power. And finally, K, we can say, is equal to 2 times 10 to the 6th power. There you go. Now, I hope this lesson was meaningful and hope you understand the concept better. Thank you.